The Tear Touch project started a couple of years ago with a few students in the lab and Dr. LaBelle, and they had known that detecting glucose in tear fluid had been around since about the 1930s. And there was also this engineering need for a non-invasive way for diabetics to test their blood sugar. So they decided they were going to try and create a device that was non-invasive so the diabetic wouldn't have to prick their finger. And that is how they chose the method of tear fluids. So their idea was you would just touch your eye, you would get a glucose reading, and it wouldn't be painful. And that's kind of how the Tear Touch project came about. And since it started, there's been about 5 different versions that students in the lab have come up with and that we've developed. And each of those versions kind of built upon the first version. So we would make one version and then improve upon that and create another version. Right now in the project, we just finished up a preclinical study. So from that, we are testing alternative designs and ways to combine designs to make our sensor even better. So that's kind of where we're at now, is figuring out what route to go with the project now and which design is going to eventually lead us to actually submitting to the FDA and going to market with our product.
When I first got in touch with Dr. LaBelle with this project, he presented as like a very innovative device, but really needs somebody to continue the work. Right now, I'm trying to work on the dry reagents so that it doesn't always have to previously inject the redox probes. Because if we think of the patient's point of view, they're not going to have some way to inject into a sensor and then measure it. So we definitely want to make something that's very easily accessible for the patients so that reduces their user error.
Currently, I'm going to be working on creating the front cushion or the head of this device. Once the device touches the eye, we want a way for it to go through the device using the capillary action that we have already created so that it's able to successfully implement the 2 parts and give us an accurate reading. This is important essentially so that people will want to use the device. They don't want to put something that might hurt in their eye. The main point of this device is to make it less invasive and to make it less painful for people. We want to make sure that what they're touching to their eye doesn't hurt. So that's the main purpose of making sure the head is soft.
This is one of the first designs that a previous student had designed. So basically it's a 2-chambered mold, and you'd have dry reagents in the front, would be like your redox probe and your enzyme, and then in the back chamber would be your liquid or like phosphate, buffer saline, and essentially you would create this mold and you would push down on this back part, and that would move into the front part. It would all mix, and then you would touch it to the eye, the device to the eye, and you would pump it. But basically, there's just 2 chambers. We decided not to pursue this design just because having the 2 chambers made it a bit complicated. So we moved into a design that combined both chambers. So you would have your redox probe and your enzyme, and your whole liquid mixture would be in one chamber rather than having a dry and a wet chamber. The next design was this basic mold right here. This is the mold that we did our preclinical study with. You would fill this part of the mold with PDMS, and this would go over the top, and you would stick a needle through this little hole right here to create the chamber. And you would put this on a hot plate, and PDMS, it hardens as it gets hot. So you leave it on there for about 7 minutes, and you take it off, and you pull your mold out, and you have a mold. But the problem with this is it takes about, to make one mold, maybe 7 minutes just on the hot plate, but before this you have to mix the PDMS, and that takes a while. And once you have your mold, you have to glue it to the sensor, and we use just basic screen print electrodes, and that can take a while as well. So maybe it's about 15 minutes per mold to create just one sensor. So we would really, in the future, we would really like to improve our manufacturing speed and maybe do hundreds at a time rather than one at a time. This mold right here that addressed some problems we were having with the previous ones. So for example, when we were gluing the previous version to the sensor, the glue that we would use would like squish out the sides and like squish into and onto the electrode, and that's bad because now the electrode has glue on it. So this version actually has it has ridges on the inside, so that kind of served as a barrier for the glue so it wouldn't go into the electrode when we were gluing it. That was one thing that we changed on this mold to try and fix the previous one. But this design actually ended up not working because the chamber that the foam would go in, so basically a little piece of foam goes in the top chamber, and that's what you touch to your eye. But in this version, it was too tall, so when you would pump the device, the liquid wouldn't come back into the device because the vertical chamber that you would touch to your eye was too tall. So we made some more changes to this one, and that's how we came up with this next device. We addressed the problem of the chamber being too tall, and so that was also fixed on this mold. And in this mold, we also added little holes to help the glue be more consistent when we were gluing. So we have to glue all these by hand. So basically, we were just trying to make it easier for us to glue the device, and so it would be more consistent every time. After these, we decided to go about trying to figure out how to do a laminated type fluidic. So that's where we came up with this method, and basically this is a bunch of different layers of different materials, and these are very hydrophilic materials. So basically this is capillary action. So you would cut this out and you would stick it to the sensor instead. So this would be kind of like your mold, except it's a laminated card. You would have a cushion on the front of this, and then the fluid would go into here and the electrode would be around here. So it's just another method of collecting the tear fluid. This is still in production, so this is kind of what we're working on right now to get the integrated cushion on the front, or to integrate it with this, and then that would create a laminated fluidic capillary action version.